In this video I'm going to be explaining the term position vector. Start off with an example. We've got our usual grid with origin at O at 0, 0, and we've got a horizontal distance in kilometres and a vertical height in kilometres. So imagine a spaceship appearing. It's at position 4 kilometres horizontally and 6 kilometres vertically in height. Now this could be a spaceship appearing in real space, or it could actually be one that you create on in a computer game. So the position vector between the origin, your point of observation, and the centre of the spaceship is given by this red line here and a letter R with an underscore. That's termed the position vector from the origin to the object. And then you can see here the vector is, you have to move from the origin 4 kilometres and in the horizontal direction and 6 kilometres in the vertical direction. So you write the position vector as 4, 6. So that's basically the vector from the origin to the centre of the spaceship. So 4 in the x direction and 6 in the y direction. Okay, so I'll show a few more examples. Got an origin point located at x equals 0, y equals 0. Then the point P at position 2, 3. The position vector from O to P is written as O with a OP with a bar, an arrow across the top, a letter A in bold or letter A underscore. The letter A in bold is used in exam papers and test papers, whereas a letter with an underscore is the format you have to use when answering questions. So we've got the x component and the y component. The x component is plus 2 units or centimetres from the origin and plus 3 centimetres in the y direction, the y component. So the column vector for A is written as x component over y component, and that's written as plus 2 over plus 3. And that's the same as moving 2 units to the right and 3 units up. So 2 units to the right and 3 units up. I'm going to show you another position vector example. Got the origin point O and a point Q located at plus 5, minus 4. So the position vector OQ, given that a vector B in bold and also underlined. So we now display the x components and the y components. See, the x component from the origin is plus 5 units or plus 5 centimetres, and the y component is minus 4 units of minus 4 centimetres away from the origin. So this column vector for B is written with x component of the y, and that's written as plus 5 of minus 4. So that's the same as moving from the origin 5 units to the right and 4 units down. That's 5 units to the right and 4 units down. Okay, I'll show you one more example. We've got points O and a point R at position minus 4, minus 2. The position vector OR, and written in lowercase c in bold and also lowercase c in underscore format. The x component from the origin is minus 4 centimetres and minus 2 centimetres in the x direction, the y direction. So this vector C is written as x component over y component, so that's written as minus 4 over minus 2, or that can be explained as moving 4 units to the left and 2 units down. So from the origin you're moving 4 units left and 2 units down. So I'll show you one more final example. So we've got the origin point O and point S located at minus 3, plus 3. So the position vector OS and that's also written as vector d with an underscore. The x component is minus 3 units, the y component is plus 3 units, so this column vector is written as minus 3 over plus 3. So that's equivalent to moving 3 units to left and 3 units up. So starting from the origin, 3 units left and 3 units up. In the following videos, I'm going to be explaining how to calculate a vector given 2 points where the origin point isn't included. Thanks for watching.